This conference will now be recorded.
Phytoconstituents are the crude drugs which are subject to a suitable method of extraction for the isolation of pharmaceuticals. Phytoconstituents, which are known as active constituents of the drug. These are produced during the process of metabolism, which we know, which we call it as a biosynthesis. So, conversion of simple chemical substances into complex substances with the help of enzyme. This process is known as a biosynthesis. So, there are two groups of phytoconstituents. The first group of is known as the primary metabolites. The second one is the secondary metabolites. Primary metabolites are proteins, carbohydrates, and the lipids, and the secondary metabolites majorly will study the alkaloids, glycosides, volatile oil, resins, and tannins. Coming to the next first classifications. So alkaloids. So the alkaloid is alkali like generally alkaloids. These are commonly used to designate the basic heterocyclic nitrogenous compounds of plant origin that are physiologically active. So when you go for the elements, the basic, they are basic in nature, the first property. Then they are present as an heterocyclic ring structure. In the heterocyclic ring, they have a nitrogen compound and they are of a plant origin and they are physiologically active. So these are the few properties of alkaloids which we define. So alkaloids are a group of naturally occurring chemical substances or naturally occurring organic chemical substances that contain mostly basic nitrogen atom. This group also includes some related compounds with a neutral and even weakly acidic properties. Some synthetic alkaloids also is present. So in addition to nitrogen, it contains a carbon, hydrogen, oxygen, sulfur, and very rarely chlorine, bromine, and the phosphorus. So here the name alkaloids, German alkaloide, was introduced in the year 1819 by the German chemist Carl F.W. Messner, and it's derived from the Latin root, that is Latin alkali means alkaloids means alkali, which in turn comes from the Arabic alqua, ashes of plants, and the suffix of Greek, that is like. Alkali-like substances. However, the term came into wide use only after the publication of review article by Jacobson in the Chemical Dictionary of Albert Ladenburg in the 1880s. So overall, alkaloids, it's a Latin word. Alkali-like substances are known as alkaloids. Alkali-like substances, definitely they will be a basic in nature, which contains a nitrogen. Nitrogen is present in a heterocyclic ring structure. If you remember these three properties, you can always write the definition of alkaloids. So how can you define the alkaloids now? These are the alkali-like substances. These are the organic chemical substances which contains the, yes, these are the organic chemical substances. You should answer me now.
Contain mostly basic nitrogen.
Yeah, tell me.
Alkaloids are a group of naturally occurring chemical compounds containing basic nitrogen.
That's all?
Heterocyclic ring of nitrogen. with nitrogen and some other atoms like carbon, hydrogen.
Then others, alkaloids are the organic chemical substances which are basic in nature, which contains a nitrogen in the where
Heterogeneous.
Heterocycle.
heterocyclic ring structure, which has to be used in a small quantities. They have to be used in small quantities. Why they have to be used in a small quantities? Because they are potent medicaments. They have to be used in a small quantity to exert a physiological action. They are used in very small quantity to exert a physiological actions. These are the organic products of natural or synthetic origin which are basic in nature and contains one or more nitrogen atoms, normally of heterocyclic nature, and possesses specific physiological actions on human or animal body when used in small quantities. So this why we use it in a small quantities if they are very potent medicaments. Potent is means what? The smaller the concentration, it exerts the physiological action. Higher the concentration, it is toxic to the human body. I think you know the what is a potent medicaments, right? If you use it in a smaller quantity, it acts as a medicine. If you use in a higher concentration, it acts as an poison. So these alkaloids also in the same way. These are the organic products uh, of the natural or synthetic origin which are basic in nature because they contains a one or more nitrogen atom in the heterocyclic ring and possesses a specific physiological action. It's very specific physiological action on human or animal body when used in a small quantities because they are the potent medicaments. This is the definition of alkaloids. So this is what is that in German it is alkaloide. So in the Latin word it is alkali-like substances is known as the alkaloids. Since it contains a nitrogen, it is a basic in nature and it is alkali-like substances. A function of alkaloids in plants. As such, I said secondary metabolites does not have a much uh, what is functions in the plants, but we'll see it will definitely have a few functions. They act as an protective agents against the insect and herbivores due to their bitterness and toxicity. I said they are highly potent in nature, so they are toxic in nature. In generally, they are toxic and highly bitter in taste. So, means going to this property, they act as a protective against the insect and the herbivorous, so which eats on the herbs. Means they, if it is bitter, definitely they'll not eat. They are in certain cases the final products of detoxification. Means these are the waste product which will be dumped into the vacuoles of a cell. And also this, since it contains a nitrogen, this acts as a source of nitrogen. So in case of there is a deficiency in the plant, so this nitrogen which will be present in the vacuole as a waste material will be used for the it will be utilized as a nitrogen source. They sometimes act as growth regulator in certain metabolic systems. Sometimes they also, since it contains a nitrogen, you know, nitrogen is majorly present in the amino acids in the proteins. So here the nitrogen acts as a growth regulator also. They may be utilized as a source of energy in the case of deficiency of carbon dioxide assimilation. So as a source of energy also they are utilized. Coming to the classification, there are three types of classification: true alkaloids, protoalkaloids, and the pseudoalkaloids. True alkaloids, they are toxic in nature, contains a heterocyclic ring structure, and they are derived from amino acids and always basic in nature. You have to just write down whenever I'm explaining the properties. Here, true alkaloids, there are three types of alkaloids. The major classification, there is later chemical classification of alkaloids is there. So here this is the basic classification of alkaloids, that is true, proto and pseudo. True is always a actual one, which is a toxic in nature. It contains a heterocyclic nitrogen that is derived from amino acids. Derived from amino acids means in the biosynthetic pathway, amino acids, different amino acids is the starting material for the synthesis of these alkaloids. Normally present in plants as a salts of organic acids. So here true alkaloids usually in the plants they are present as a salts. Now for example, quinine, I think you know the quinine drug. It is an anti-malarial drug. So quinine is present as a quinine sulfate or the quinine hydrochloride. That is, we call it as a salt. It is not as a base form as a quinine. Instead, it is present as a quinine hydrochloride or the quinine sulfate. So coming to the true alkaloids, they are toxic, contains a heterocyclic ring structure in that nitrogen is present. They are derived from amino acids. They're always basic in nature. These are the four properties which you have to remember. The fifth one is they are salts of organic acids. Toxic, contain heterocyclic ring. In the heterocyclic, it contains a nitrogen. This is derived from amino acids, basic in nature. These are the salts. These are present as a salts. If you write, it is enough. They are present as a salts. Next one is protoalkaloids, or we call it as another name, amino alkaloids. What we call it as protoalkaloids or the amino alkaloids. You people are alive? You are listening?
Yes,
Yes,
ma'am.
yes, ma'am.
Yeah, ma'am.
Yes,
Yeah,
ma'am.
ma'am.
Protoalkaloids are. Do you have any doubt with the true alkaloids?
No, ma'am.
Any doubts? Here, true alkaloids are basic in nature because they contain a nitrogen in the heterocyclic ring structure. Then, then what else the properties? They're toxic. They contain a heterocyclic. In the heterocyclic ring, what it contains?
Nitrogen
Nitrogen.
atom.
Nitrogen. Nitrogen.
Nitrogen. These are derived from
Amino acids.
Amino acids.
amino acids. They are present as a salts. Okay. Next one is protoalkaloids or the amino alkaloids. These are derived from amino acids and do not have nitrogen in a heterocyclic ring. Instead of heterocyclic ring, they are present in a as a this nitrogen is present in a side chain. These nitrogen atoms are not present in the heterocyclic. Now, what is heterocyclic ring?
Ring with two different functional group, ma'am.
No, do different functional. No. What is a heterocyclic ring? What are heteroatoms?
Ma'am, atoms of
attached
two
with
different
attached with
elements.
4 bonds.
What are they? Name some.
Nitrogen, carbon, oxygen.
Carbon also.
No, ma'am. Sulfur, chlorine.
So next class, tomorrow you're going to tell me what is a heterocyclic ring, what are heteroatoms. So here nitrogen is not present in the cyclic ring structure, instead of it is present in the as in a side chain. These are also synthesized from amino protoalkaloids or amino alkaloids are derived from amino acids, and they do not possess a nitrogen in the cyclic ring structure. Instead, it is present outside the ring. For example, ephedrine. The next one is pseudoalkaloids that are not derived from amino acids but have a nitrogen in the heterocyclic ring. And many steroidal and terpenoidal alkaloids belongs to the pseudoalkaloids. And why we call it as pseudoalkaloids? Because they do not show many of the typical characteristics of alkaloids and gives a false positive reaction with the alkaloidal reagents, and many a times they don't give a reaction at all for the chemical test for the alkaloids. There are four basic tests for alkaloids. So these gives a false positive, or they do not give the positive test for the alkaloids. They do not respond to the test for alkaloids. So they are known as a pseudoalkaloids. First property of a pseudoalkaloid is they are not derived from amino acids, but they have a nitrogen in the heterocyclic ring structure, whereas the proto or the amino alkaloid, the nitrogen is not in the cyclic ring structure. Instead, it is present in a side chain. It do not show many of the typical characteristics of alkaloids. One among that is it does not show the positive reaction for the test for alkaloids, or sometimes it shows a false positive reaction for the alkaloidal reagents. What are those alkaloidal reagents? Dragonroff, Hager's reagent, Wagner's reagent, Dragonroff, Hager's, Wagner's, and Mayer's reagent. These are the four reagents which we use for the test for alkaloids. This pseudoalkaloids is called as a pseudoalkaloids. First property. The second property is they do not derive from amino acids, but they contain the nitrogen in the heterocyclic ring. In this pseudoalkaloids, many steroidal and terpenoid alkaloids will come. Example is caffeine. Caffeine is present in tea, coffee. So this is a caffeine, and one more is quercetin. Coming to the properties of alkaloids, as we have seen, classification and the definition of this alkaloids. This contains a nitrogen, usually derived from an amino acids. It's highly bitter in taste and generally white crystalline solid. Except nicotine. Nicotine is a brown liquid. These are bitter in taste. They are generally white crystalline substances, white crystalline solids. One exception is nicotine. Nicotine is a liquid. They give a precipitate reaction with a heavy metallic iodides. Like caffeine does not precipitate like most of the alkaloids. So when you see the test for alkaloids, either potassium iodide in iodine or mercuric iodide in a iodine or potassium bismuth iodide in a iodine. So these metallic heavy metal iodides It gives a precipitation. It is a major property of alkaloids. So by using this property only, we are just checking this is alkaloid or not. That's why pseudoalkaloid does not give a test for this heavy metal iodides or the test for alkaloids. Like example, caffeine. Alkaloids are basic in nature. They form water-soluble salts. Most alkaloids are well-defined crystalline substances which unite with acids to form salts. So these are basic in nature and they form a water-soluble salts. They are bases. Bases means free bases. Like sodium hydroxide is a free base. When it reacts with a something, base acts with a salt, it forms an NaCl. So same way, it is just a free base. It freely reacts with the salts. It freely react with any acids and forms a salt. See, most alkaloids are well-defined crystalline substances which unite with acids, which reacts with the acids to form a salts. Like sodium hydroxide is a free base. When it reacts with the acid, it forms an NaCl plus H2O. In plants, they may exist as a free state, means as a free base. Like quinine as a quinine, as a salt, quinine salt, quinine hydrochloride or a quinine sulfate, or as an N oxides. So N oxides are also not stable. Either the base is stable or the salt is stable to extract. They occur in a limited number of plants. Nucleic acid exists in all plants, whereas morphine exists in only one plant species. Means usually these we say caffeine exists in a tea also, in the coffee also. It is the same entity, same molecule, which is present in both the in two different plants. That's what we are trying to tell in the last. So, but in case of a morphine, morphine is present or it is specific to the particular species of a plant. If not, many of the alkaloids present in many plants. So leave that. Coming to the again the properties, they are basic in nature. First one. Everybody is there? You people
Yes,
are there?
ma'am. Yes, ma'am.
Yes, ma'am.
You are understanding?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
What are the properties? Tell me the properties.
Ma'am, they are white
Ma'am, bitter
crystalline
in taste.
White
They are
crystalline
usually
substances. One.
White
bitter in
solids.
taste, exception of nicotine, which is brown in color, liquid.
Liquid. Brown liquid. So color is brown and it is a liquid. Otherwise, the all the alkaloids are in white crystalline solids.
White crystalline.
Okay?
Okay, ma'am.
Yeah, white
Yes, ma'am.
crystalline solids. But one exception is liquid, that is a nicotine. One exception again is a color
Nicotine.
brown. Yeah. Then next property.
They
They
give
give
a
a
precipitate with heavy iodides.
heavy metal iodides.
People is there? Miss Fal? Sandeep, Miss Fal is there in the class?
Yes, ma'am, he was there.
Is there?
Ma'am, now he's offline, ma'am. He's offline. I think net issue. 3 times he joined, but I think net issue. He's having net issue.
Okay, leave now. So the first property is it is a crystalline substances. Crystalline one. Oh my God. Okay, the first thing is they are bitter. Okay. Second one is their color, or you can say it is a white crystalline substances. Exception is nicotine, which is in a brown liquid. Kushal, what is the next property?
They produce a precipitate, ma'am, with a heavy metal iodides like caffeine.
With heavy metal iodides. So they give a precipitate reaction with the
Heavy.
heavy metal iodides. In the bracket, you can say heavy metal iodides are the test for alkaloids. They give a precipitate. See, this is very important. Whenever I give a test for alkaloids, there are 4 tests which I'll explain. When I give the test for alkaloids, you will always say that it's a color. It is not a color which obtained in the test alkaloid test. It is always a precipitate. So I think you know what is a precipitate in the color reaction. Color reaction always. So reagent might be any color. So when you put that reagent into the one particular substances, it produces a different color. If it produces a different color, then it is a color reaction. Here, what we are telling in the alkaloids, it precipitates. It is a there are I think in the chemistry, inorganic chemistry, you would have studied opalescence, precipitate, and the turbidity. Opalescence means what? What is opalescence? Pooja, what is opalescence?
Yes, ma'am.
What is opalescence? You have done the limit test, right?
Yes, ma'am.
Yes. Yeah, in that you will study, chlorides, limit test for chlorides. It passes the limit test or fails the limit test based on the opalescence. Now, what is opalescence? Anybody in the class? I'll give you
White
1 mark.
color, ma'am.
White color, the
White coloring
dark,
is
milky white color.
Okay, precipitate means what?
forming of salt, like, ma'am, at the bottom.
Okay, turbidity means what?
Turbidity, color, ma'am. Colored one.
Like, like
Is
cod,
not a
The
ma'am,
color.
like
purple
cod type.
color.
Now we'll
White.
explain into 3. Now I'll explain. Opalescence is like a milk. Okay, precipitate is like a buttermilk. Turbidity is like to what we can compare turbidity now?
Ma'am, those are dark colors, no, ma'am.
Curds.
No, turbidity. Not a dark. See, it is not
Ma'am, it is like a
pertaining
cod
to the
type,
color
little
now what we are
cloudy.
talking. It is about the precipitation. Type. Yes. Anything when we say the precipitation, something is getting out of the solution is called the precipitate. Now, in case of opalescence, it is not coming out of the solution exactly. It is there in the solution, but the solution will turn into a milky color or milky type. Clear solution, when it turns to the milky, we call it as an opalescence. When it slightly comes out of a solution, we call it as a precipitate. That is nothing but the like a buttermilk. Buttermilk will not be like a milk. Milk is a clear liquid, whereas the precipitate, it's slightly a buttermilk, which you can see the particles running around in the buttermilk. And if you keep it aside for some time, the buttermilk means the precipitate will settle down. In case of a turbidity, the whole solution, whatever that was there in the solution, the solid which has got solubilized would just comes out of a liquid, means like a curd. However you keep it, how long you keep it, it will not get settled down. It has become turbid, right? That is called the turbidity. Hope you will not forget now. So it doesn't give any color reaction alkaloids, it gives a precipitation reaction. Okay, when you add something to the alkaloids, it should give a precipitation, means something should come out of a solution. So it is not that the color change of a color, we don't say it as an, it is giving a positive test for the alkaloids. So it gives a test, precipitate test with a heavy metal iodides. Then they are basic in nature. They form a water soluble salts. The most alkaloids are well-defined crystalline substances which react with the acid to form a salts. Salts exist in a free state or a salts or in oxides. This is enough. They are colorless, one thing. They are crystalline substances. So they're colorless, crystalline. Give an example, means give exception, nicotine. Exception, they are colorless or the white crystalline substances. Exception is this brown liquid. The colorless, usually they are colorless. You can give an exception is a betadine. It has a color, a red color. Betadine, which is present in the beetroot, it has a color. These are the colorless crystalline substances. They are bitter in taste. They are basic in nature. They react with acid to form a salts. They occur in the plants as a free state or a salts or the N-oxides. You can see they are alkaloids are crystalline solids. Sometimes they are amorphous in nature. Exception is emitting. Example for amorphous is emitting. Sometimes they are not crystalline substances. Instead, they are liquids, either volatile or non-volatile. Volatile or nicotine or conine. Non-volatile is a pilocarpine and hyoscine. These are the liquid alkaloids. Otherwise, all alkaloids are crystalline in nature. Coming to the color, alkaloids are colorless, but some are colored. That is colchicine, betadine, and berberine. Colchicine and berberine are yellow. Betadine is red. Canadine is orange. The salts of sanguarine are copper red. These are the few exceptions I'm telling. Otherwise, they are crystalline solids, they are colorless. Exceptions are nicotine, conine, pilocarpine, hyoscines. These are liquid in nature. They are colorless solids. Some are colored. Example, betadine, berberine, colchicine. Coming to the solubility, alkaloid bases and their salts are soluble in alcohol. Alcohol is a polar solvent. Generally, bases are soluble in organic solvents and insoluble in water. So, free bases, what we call it as, either they are not the salts, free base, they are insoluble in water, but salts of the base are soluble in water. Now, in the solubility, there are three categories. First one is, there are three categories. The first one is the free bases and the salts are soluble in alcohol. The second category, the free bases are not soluble in the water, they're soluble in only in the organic solvents. Third category, salts are salts of free base. Free base, when we react with the acid, it forms as a salt. These salts are soluble in the water. It's clear, I think. Now, alkaloids are solubility when it comes. The salts and the free bases are soluble in the alcohol. The free bases are soluble only in the organic solvents like chloroform, benzene, ether, petroleum ether, all this. The free bases are soluble only in the organic solvents. Whereas in case of a salts soluble only in the alcohol or the water. Means alcohol, we consider it as an universal solvent where the salts and also the bases are soluble. If you leave out this alcohol, bases are soluble in organic solvents, whereas salts are not soluble in like if you take a sodium chloride is not soluble in petroleum ether or the chloroform, but it is soluble in the water. Whereas free bases are not soluble in the water, but they are soluble in organic solvents. It's clear? Is it clear?
Yes, ma'am.
Can you tell somebody to tell solubility?
Both alkaloidal bases and their salts are soluble in alcohol.
Hmm.
Generally, the bases are soluble in organic solvent and insoluble in water.
Hmm. Salts. It occurs as a free basis and salts. Previous slides you have seen. Now the free bases are soluble in organic solvents. Salts are soluble in water.
Water.
Salts are not soluble in organic solvent, and the free bases are not soluble in the
Alcohol.
what?
Alcohol.
Yes. Free bases are not soluble in the water. But the others, you talk, man. I don't know what you will do. Unmute yourself, everybody. Balaji. Balaji.
Hello, ma'am.
Balaji. Yeah, tell me what was my question? What was my question? Alkaloid bases and the salts are soluble in useless fellow, wherever you meant Balaji. Hey Balaji, are you there?
Ma'am. Ma'am.
Yeah, you're not listening to the class?
Listening, ma'am.
Then tell me, bases and salts are soluble in what? Alcohol. Somebody is telling alcohol. Who's telling? Where were you, Balaji?
Ma'am.
What, ma'am? Where were you in the class? I'm explaining so much in the alkaloids. I don't know where were you in the class. You were not there in the class at all. Somebody is telling for you it's alcohol.
No, ma'am.
Wait, Balaji, you please be there in the class. Otherwise, you
Okay,
will
ma'am.
not understand again what are alkaloids. Nikhil? Nikhil? I don't know where you people will go off, man. After see, just you will attend the class and you will just leave the class and go. Rahul, you should
Yes,
remember this
ma'am.
Nikhil. Yes,
Hello.
Rahul.
Yes, ma'am.
This is also soluble in.
Ma'am, alkaloid base are usually soluble in alcohol and but insoluble in water, ma'am.
Which one basis?
And salt and what, ma'am?
Bases are soluble in
Soluble in alcohol, ma'am,
and
and al and water, ma'am.
oh, bases are soluble in alcohol and organic solvents. Okay,
Yes, ma'am. Yes, ma'am.
salts are soluble in
Salts are soluble in water, ma'am. Insoluble in organic solvent.
Hey,
but soluble in
Water, ma'am.
yes. Salts are soluble in water and alcohol. Bases are soluble in alcohol and organic solvents. Don't leave class and go off somewhere. Satvik Roy?
yes, ma'am.
Yes. Exceptions, can you read Satvik?
Ma'am, salts, salts insoluble in water, quinine monosulfate, salts insoluble in organic solvent, lobeline and epitrophin hydrochlorides are soluble in chloroform.
So exceptions are bases soluble in water, caffeine, ephedrine, codeine, colchicine, pilocarpine, and quaternary ammonium bases. So we are, you see, bases we are telling they are soluble only in alcohol organic solvents. These bases like caffeine, ephedrine, codeine, colchicine, pilocarpine, and quaternary ammonium bases, these bases are soluble in water. These are the few exceptions. Okay, but some bases like insoluble or sparingly soluble in organic solvents are morphine in ether, theobromine and theophylline in benzene. Means we say that all the bases are soluble in organic solvents, but this morphine is not soluble in ether. Theobromine and theophylline is not soluble in benzene. These are the few exceptions. Clear? According to us, bases are not soluble in the water. Adike, one exception is caffeine, ephedrine. These are the few bases which are soluble in water. According to us, bases are soluble in the benzene. These are the few exceptions. Salts are usually soluble in water but insoluble and sparingly soluble in organic solvents. That is very clear. There is few exceptions in that is salts is insoluble in water. Quinine monosulfate. This is insoluble in water. Quinine monosulfate. Quinine hydrochloride is soluble in water, but quinine monosulfate, the solubility is sparingly soluble. I think 1 part in something around 700 or something, some parts. Salt soluble in organic solvents. Lobeline and apotropine hydrochlorides are soluble in chloroform. So usually salts are not, excuse me, salts are insoluble in the organic solvents. Exceptions are Lobeline, this apotropine, these are soluble in organic solvents like chloroform. Is it clear? These are the few exceptions I'm giving. First, you write off the solubility and write the exceptions. Bases are soluble in water. Examples are, these are the exceptions. Instead of that, you can write exceptions like bases are soluble in water. Exceptions, caffeine, ephedrine. Bases are insoluble or sparingly soluble in certain organic solvents. These are the few exceptions which are not soluble at all. Salts are usually soluble in water. Examples, exceptions are quinine monosulfate. This is insoluble in water. These are not soluble in the organic solvents. Exceptions are lobeline. This is clear?
Yes, ma'am.
Ma'am.
Yes, ma'am.
These are optically, these occurs as optical isomers. This shows a different physiological activities. Means these occurs in L isomer and a D. Means L means LIVO and the D. Means if it is turning the towards the right hand side, if the plane of the polarized light is turning towards the right, then it is D. It is turning towards the left, then it is LIVO. This ephedrine existing in the LIVO form and the D form both will have a different action sometimes, or the amount of the physiological activity will be different. Like L-ephedrine is, LIVO isomer of ephedrine is 3.5 times more active than the dextroephedrine. L-ergotamine is 3 to 4 times more active than the D-ergotamine, dextroergotamine. Dextrotubocurarine is more active than the corresponding L form. So quinine LIVO form is antimalarial, whereas dextroisomer is, that is quinidine we call it as, it's an antiarrhythmic. Quinine is there. So I think next class you just remind me, I'll show you the structures. Quinine is same, the structure is same, but one hydrogen above the plane and the below the plane will see both are above the plane, then it is an antimalarial. One is above the plane, one hydrogen, and one is below it will be formed as an, it will be called as an quinidine, which is an antiarrhythmic drug. So you can never get confused to quinine with a quinidine and cannot be given. Like instead of quinidine, if you give a quinine, it acts as an antimalarial. Instead of where you have to give as an antiarrhythmic drug, arrhythmiasis is occurring, where your heart rate is too much, where you have to give a quinidine. If you give a quinine, probably the patient will collapse there itself. So we say the racemic mixture, like atropine, is physiologically active. We say usually the racemic mixture of the drugs are not usually active. They are optically inactive, or physiologically also we say it is inactive. But you can see in the alkaloids, DL, racemic mixture of atropine, is physiologically active. So to conclude, they exist in the L and the LIVO form, and we have to find out which form of this is more effective, or which form is acting as what. Means what is its physiological action, what is a physiological L isomer and the D isomer, and if it is existing in a racemic mixture, is it active or inactive. This is a few chemical tests. This is the one I was telling. These are the basic chemical tests. If I ask you to write the chemical test for alkaloids, you're going to write the chemical test. These are the Mayer's reagent test, Dragonroff reagent test, Wagner's, and the Hager's. Mayer's reagent, it gives a cream colored precipitate. Dragonroff gives a orange colored precipitate. Wagner's gives a red brown precipitate. Hager's gives a yellow precipitate. The same thing I'll continue in the next class of this. Okay, I'll explain this again in the test I'm telling you. I'll explain in the next class. Clear?
Yes,
Yes,
ma'am.
ma'am. Ma'am, you didn't
Ma'am.
share the note, Senna,
Okay.
hormone.
Which one? Which one, Sandeep? I have to give you the notes.
Senna, plant hormone.
Plant hormones I have not given. A stupid fellow, it is there in that this only, you see, cultivation collection only.
No, ma'am.
Cultivation collection one Word document I have given, no? I have sent long back. The factors affecting. In that it is there. That is enough. If not, I'll share the slides. Okay. Sandeep, speak out.
Yes, ma'am.
Anything else is there to be given? Then I have to
That
give.
only, ma'am.
Senna, I'll share with you. You just check it out, Sandeep. If it is not clear or you're not understanding with that notes, I'll share the PPT. PPTs are very clear of the hormones. Okay.
Okay,
Okay,
ma'am.
ma'am.
Bye.
Thank you, ma'am.
Bye, ma'am. Bye.
Thank you, ma'am.
Thank you, ma'am.